okay, because we did it last section. So the last unit we looked at, how do we tell whether or not we have an infinite number of solutions, no solutions, or where lines cross. And then we were asked to find the intersection point using the graphing method. Bless you. Today, we're going to just simply do algebra in order to solve it, which is already something we did last section as well. So the first method to do this is the substitution method. And in the substitution method, you get either isolate x or y, and then substitute it into the other equation. Then we solve it, and our goal is to find out where are these two lines going to cross. So it is nothing new. We have done this, we did this. So take a look at an example. I've got 5x plus y. 5x plus y is equal to 11, the first equation. So this is on page 191. 5x plus y is equal to 11. That's equation number 1. Now I'm going to label them. I'm going to label that one A. Then I have 2x plus 3y equals 7. I'm going to label that B. Now my objective here is to find out where these two lines cross at. So where they cross at is at a coordinate, x and y. And in the method that I'm going to use, I'm going to isolate one of the variables from one of the equations and substitute it into the other equation. So then I only have one variable to work with, solve for, and then go from there. So looking at the two equations, which one is easiest? Of all of that there, which would be the easiest variable to isolate in which equation?
Y.
The y in the first equation. Agreed? Fair enough. So I'm going to use equation A, and I'm going to subtract 5x to the other side. So I get y is equal to negative 5x at 11. Simple, right? Something we've already done. Now, in the second equation, instead of y, I'm going to put this into the equation, and then I'm going to solve for the x. So it looks like this. 2x plus 3 times, instead of y, minus 5x plus 11 equals 7. So this method is called substitution. I isolate one variable from one of the two equations, and then I substitute it in for that variable in the second equation. So on equation A, I isolated the y, then I substituted it into equation B for this value right here. Now I want to solve it. 2x plus minus 15x plus 33 is equal to 7. So I have them on the same side already, the x's. So I just want to simplify this a little bit. So I'm going to get minus 13x plus 33 is equal to 7. Right? Now how do I isolate this minus 13x? How do I get it by itself? Not yet. I need to get the x value by itself. So what's the first thing I need to do? Subtract 33, exactly. Minus 13x is equal to, and I subtract 33 from 7, and that gives me minus 26. 7 subtract 33, minus 26. Now what do I do to get x by itself? Divide by negative 13. X is equal to 2. All right, so now I know where the x coordinate is where these guys cross. Now I need to find the y. What do you suppose I do to get the y? Put this value into one of the two equations.
Does it matter which?
No, it does not matter. And what I'll do is I'll prove it with the second one. So I always do it with the easy one. Okay? So the easy one meaning I've got the y by itself, so I'm going to put it into that equation. So this is my second kind of step in the process. So I've got 5 times 2 plus y equals 11. Right? Because 2 goes in for x. 5 times 2 is 10. 10 plus y is equal to 11. Okay, so far, how do I get y by itself? Subtract 10, y is equal to 1. What's the coordinate that they cross at? 2 and 1. All right? Now, if I wanted to check this, which you can, I would put it into the other equation to make sure it works. So I would have 2 times 2 plus 3 times 1, and it should equal 7. 2 times 2 is? 4 plus 3 is? I got the right answer. You can guarantee your work every time now. That wasn't very long. It took me, what, 3 seconds to check it? To figure out whether I got it right or wrong, right? Okay? So this method's called substitution. We're going to do 3 methods. This is the substitution method, okay, that we want to do it with. So I'm going to do one more on this method here. Of course, I got to throw a word problem right away. So look at page 192. Ryan bought 3 tickets and 6 hot dogs at an Edmonton Rush lacrosse game. The total cost of his purchases was $153. His friend Kerry bought 1 ticket and 3 hot dogs and spent $54. What was the price of a single ticket and a hot dog? So we need to use these 2 equations in order to solve this. Okay? So the first thing I'm going to do is I'm going to just establish what I've got for each. X is going to be my ticket. Y is going to be the cost of a hot dog. Okay? Equation A. Ryan bought 3 tickets and 6 hot dogs and it cost $153. X plus Y equals 153?
3x plus 6y.
3x plus 6y. I have 3 tickets and 6 hot dogs, right? So you're on the right track. So 3x plus 6y equals 153. Right? Equation B is okay. So looking at the 2 equations right now, which one would be the easiest variable to isolate of all those variables?
X on the second equation.
X on the second one. And what does x equal in the second one? If I get x by itself, what does it equal?
The cost of the ticket.
No, okay, I understand
Negative
it.
3y plus 54.
Thank you, Casey. I'm going to move this over, right? You get x by itself, correct? So I'm just going to subtract it. So I get minus 3y, add 54. Right? Now what do I do with that now?
Plug it in for X and then.
Awesome. Plug it in for x in the original equation, the A equation. So 3 times. Now instead of x, I'm going to use this. Minus 3y, add 54, plus 6y equals 153. So now what I've done is I've eliminated one of my 2 variables. And I'm only going to work with 1. And again, this one was different than the first one because in the first one I isolated y. In this one I isolated x. Whatever's easiest. That's the process you take.
So how do we know what number goes in front of like negative 3y plus 54? Like,
It's right here.
oh, that one you take?
Well, I'm not taking it. What am I doing? I'm taking whatever x is, which is this, and I'm substituting it in for x in this equation.
Oh, okay, I was getting confused because we were doing the second one and
Yep.
put it into the first one.
Okay? So that's what I'm doing. I'm taking the x, what this was equal to in the second one, and substituting it in for this here. Now notice, I always use brackets where I make a substitution. This could have been 3x, but I substituted in minus 3y plus 54. Now I solve it. Minus 9y, add 162, add 6y equals 153. That means that minus 3y, add 162 equals 153. Minus 3y is equal to, subtract that, minus 9. So I subtract 162 over here, 153 subtract 162. 153 subtract 162 is minus 9. So what does y equal? 3. So how much is a hot dog? $3. Let's find out how much a ticket is then. So I'm going to use b then, because that was the easier one. X plus 3 times 3 equals 54. Right? Again, notice that what's in the brackets, what I'm substituting. X is equal to 54 subtract 9, which is 45. So how much was a ticket? $45. How much was a hot dog? $3. And I got that because this is where these two lines would intersect at if I were to draw them up. Okay? And again, I should prove it. So if I use this one to solve it, then I would use that one to prove it, just to make sure. So I go 3 times 45 plus 6 times 3, and that should equal 153. 3 times 45 is 135. 135 plus 18 is 153. I got it right. Again, isolate the easiest variable that there is, and then use the substitution. Okay? Any questions about this guy? All right, let's try one on our own here. Here's the very first one of your questions. Whoops. Again, I would. How does this change? X is equal to y plus 2. B is equal to
X plus Y equals 1.
that. Okay? So which one's easiest to isolate?
They're both
The
easy.
X for A. Already X.
Because it's already isolated. Exactly. So I know what X is equal to in A. So why don't I put it in B for Y, or for X, sorry. So, I know this is equal to this already, right? So let's put this in for X down here. So what do I get? Y plus 2, add Y equals 25. It was already isolated. Easy question. Right? You don't have to do any work. So now, get rid of your brackets. That's going to give me 2Y, add 2 equals 25. 2Y equals 23. Y is equal to, oh yeah, can't make it that easy. 23 over 2. Yucky. Bless you. Okay? So now, how do I find out what X is? How do I find out what X is?
You substitute that in for Y.
Into one of the two equations, right? Let's use equation A. X is equal to 23 over 2, add 2, equals 23 over 2, add 4 over 2. On the denominator, oh boy, fractions again, yep, E, 27 over 2. So there's my solution, 27 over 2. And again, I'm talking coordinates, so I like to see my answer as a coordinate at the very end. Because I'm talking, I think we're all allergic to something, not just me.
Yeah, Casey.
Very well played. It's math. Clearly it's not, I think it's fine myself.
Probably, yeah.
You're killing it. Okay, there you have it, and then I would prove it. Put that in that equation there, so I'd have 27/2 plus 23/2, it should equal 25. 27 and 23 make what?
50.
50. 50 divided by 2? All right. Okay, that's it.